Welcome everyone to this Arguza webinar, where we will show you how to democratize AI using Tableau. I am Luca, a senior consultant at Arguza and Tableau certified, and I will guide you today across this demo. But first of all, why should we consider automated AI at all? So 90% of AI projects do not make it into production. And this is due to overhead in setting up and maintaining the systems required to put these models into production. Also difficulties in explaining the models for compliance, for example, and lack of monitoring. Models need to be monitored for drifts and see if the data are still relevant. And automated machine learning is the solution to all these problems. You can train and deploy models without coding knowledge, so this is much faster. And also models can then be monitored because the platform deploys the model and so makes available also the tools to monitor them. And of course, you have standardized indicators for performance and accuracy. But let's dive directly into the demo. And here is the scenario we'll work on today. So there is a streaming service. You can imagine Netflix. It's not actually Netflix, but you can imagine just for an example. And they do marketing campaigns, and as a consequence of these campaigns, users can switch to premium or not. The goal for today is to train a model on historical data and then predict if users will buy premium or not, in a way that the marketing teams can use this information and these predictions to optimize the campaigns. Okay. So this is the interface in Salesforce that includes all the Einstein services, and Einstein is the machine learning service of Salesforce. As you can see, there is a Tableau icon up there that allows us to go in the Tableau CRM Analytics Studio, where we can train our models. So first of all, what we should do is loading a dataset. So we can create a new dataset, and we can use, of course, databases and different types of sources. And in this case, we will use a CSV file, but you can also use databases or, of course, use directly Salesforce data sources. So we will click on the CSV and then go and pick up our file, which is in here, client conversion data demo. Next. Of course, Einstein helps us setting up all the parameters for the files, but we can modify if we want. And then let us have a look at the data and customize the way it is loaded. For example, date formats or other things of this kind. In this case, we can just keep the default values set up by the tool and upload the file. While Einstein is uploading the file, I will show you how it looks like. So this is the data. We have an index and then user information. It's Swiss users. So we have age, whether they are registered to the newsletter or not at the moment of the campaign, the gender of the users, how many accesses they have done in the last 6 months, if it is a new user or with a status of already users, which is defined as an age at the company of more than 6 months, the canton of residence, and the month in which the campaign was sent. And finally, if we got a premium conversion or not. So you can see behind that Einstein has loaded our data set. We can watch the data in this interface, but more importantly, we can create a story. A story is the way Einstein calls models. So a story is simply a model to predict something. So in here we have to tell it what we want to analyze. We want to analyze the premium conversion column, and we want to maximize the conversion to yes. So people that actually convert to premium. And then we type next. We do a complete analysis, and then we could just hit and train our model directly. In this case, I want just to do another step. So we'll do click on manual. When we click on manual, we have the option to select a few and tweak a little bit the algorithms that will be used, and also to change a little bit the columns that are used for the modeling. In this case, we want to remove gender because we estimate that gender is not ethical to be used in this sort of analysis. So we just uncheck gender, and we can go on and create the story. Okay, so Einstein is in its laboratory. He will crunch data and create models and insights for us. It will take just a few minutes, but for the demo, since we don't want to wait, I have already created the model with the same data. And we can have a look at what it looks like, what insights Einstein gives us. So at the top here, first of all, you have the variables that affect the most the passage to premium. So you have, for example, that if the month is towards the end of the year, November or December, we have a much higher probability to go to premium. Also, if users access many times, they have a higher likelihood to pass to premium, which makes sense because it's users who actually use the platform who will want to go to premium. And also we have people that are already users and registered to the newsletter have a higher likelihood. On the opposite side of the spectrum, we have that new users normally do not go to premium, and also young users tend not to buy premium. We can also click on single columns, variables of these analysis, and to have insights about these. So here you can see that in the summer we have the probability to go to premium lowers, and towards the end of the year it goes up. This can make sense. Maybe it was not obvious, but in summer people do not want to be bothered with marketing campaigns. They are on holidays, and towards the end of the year, instead, they receive their bonus, and so they are happy to spend a little more. We can also have a look at accesses in the last 6 months, and we see that they tend to plateau. So in here, you have that when you reach about 50 accesses, people already have a good likelihood to pass the premium, and then it stays the same. So we could, for example, choose to target campaigns only to people who crossed the 50 accesses line. We can also have a look at Canton to see something interesting. If we look at Canton, you see there are fairly big variations. But here, Einstein tells me that these variations are non-significant. What does it mean? It means that the differences between cantons are only due to random fluctuations. So essentially, there is not enough data to say that these variations are statistically significant. This is a feature of Einstein that I find very useful, because otherwise we could look at this graph and draw conclusions that are not correct, just because we do not see automatically the significance of the data. So in practice, there is no difference, no statistical difference between the behaviors in different cantons. On top of all the insights that we can have to explain the model result, that helps us explaining exactly the model and also a bit for compliance. We can also find information about the model itself and how accurate it is. For example, up here we have the AUC, which is a measurement of accuracy. You have in every indicator little descriptions that allow you to understand a little bit better and what the indicator means and what value you're looking for. In this case, we look for values next to 1, closer to 1, and we have a very high value here, so the model is pretty accurate. We can also Einstein gives us also tools to place the thresholds, because what happens is that normally machine learning models output a number, a probability, and then to decide if it's premium or not, we have to place a threshold and say if the probability is higher than a given probability, we will consider the prediction to be passing through premium or not. You can see that here the tool already optimized the threshold for us, but we can change the threshold how we want. This might depend on the use case, and we can have a look at these confusion matrix containing false positives and false negatives to understand why. So in here you have a little matrix where you have the positive cases, so the people who passed to premium and which were predicted, who were predicted to pass to premium, and they actually passed to premium, and people were not predicted to pass to premium and actually did not pass to premium. And in the other two elements, we have the opposite, so people who passed to premium even though they were predicted not to, and the inverse. So ideally, we would like our model to be all on the diagonal, but no model is perfect, and we always have a component of false negative or false positive. But we have cases where we want to optimize the threshold to have, for example, very few false negatives, like this way. Of course, the false positives will increase. This could be, for example, because we want to be really sure to catch the people, so we don't want false negatives, because anyway the model is a first step, then we will take other step manually, so we want to catch them all, and so we want a threshold that is pretty high. Another case would be for really automated, completely automated decision. We might want to have really high, really low false positives, in a way that if we take a decision, we are really sure about it. In model evaluation, you have several indicators, so it's not only AUC, and we can have a look also at the gains and lift chart. So the gains chart tells you what is the impact of the model. So if I just took decisions randomly about people passing to premium or not, how worse would I do with compared to using the model? Well, it seems that for a good part of the data, we have about a 3.5 times more probability to predict the correct passage to premium if we use the model instead of just taking a random decision. Of course, then you have a sum of the data that is really uncertain, so that it's people that have properties that really do not allow us to give an answer. And in this case, the model is much more similar to a random answer, but for most part of the data, it isn't. So we can have a look at the impact of the model. But enough for explaining the model, and let's try to use it in Tableau. So in here I have a Tableau dashboard where I have my analytics, Einstein analytics extension that allows me to predict live using my model that I deployed. I actually didn't tell you how to deploy the models. So to deploy the models, you just click on the corner, and there is a deploy model button, so we can get started. And it's really simple. You have to decide if you're updating an existing model or creating a new model, and then you just type next, and you type next up to the end. You can choose in here which variables to include as actionable variables. This could be, for example, the month of campaign and the user status. And this will be used by the tool to give recommendations. Normally, there are variables where you can make an action on, because the tool will exactly recommend this action. For example, the month of campaign, we can change the month of campaign. We can decide when to make our campaigns. And the user status as well, we can wait for people to be in the platform since some time before launching the campaign. So we can take decision and actions over these variables. And then just summary and you deploy. In this case, I have already deployed the model, so I will use the model which is already deployed. By the way, in here next to it, this is the model that I actually trained before, and you can see that in a few minutes while we were speaking, it is finished. Okay, so we go to Tableau, and here we have the prediction. It looks like that 29% of people in our new data, is not the historical data, are predicted to go to premium. And here you can see the top predictors. So again, it's if in the month is December, and if they are already users, they're likely to pass to premium. And at the bottom, you have also recommendations to improve these values. For example, if you switch the campaign month for everybody to 11 or 12, so to December or November, you will switch from 29% to 41% probability to pass to premium. Also, if people are already users, this will increase by 11%. And if you make them register to the newsletter, this makes the prediction increase by 9%. This tool stays interactive, so I can click on objects and have the predictions for the objects I selected. For example, let's see if people, the predictions only for people that register to the newsletter, and they have 41% probability to pass to premium, and for the ones that did not register, I have 41% probability. And having this interactivity really allows us to gain the most insight from our models, because, for example, you could click on 15 and see that these people have a really, really low probability to go to premium. And so maybe we want to market specifically to these people with or add some functionalities to the product that are specific to young people in their teens. On the other hand, as you can see in the distribution of ages, we see that these people are really a small population in our in our platform. And so if we really want to have an impact, we want more to consider people in their 30s and 40s, because they are the most of our users, and so they are as well the most people who can pass to premium if we target a campaign to them. Okay, but how did I make this little tool next to my dashboard? I can show you. So I go in another dashboard just for the test, and you have this objects extension, which you can use in Tableau. So you can drag the extension into the dashboard, and it opens, it gives you the choice of which extension you want to use. Extensions in Tableau are really varied. You have extensions that make you allow you to use new visualizations not natively included in Tableau, or other things. But on top you have Einstein Discovery, so the extension that connects to Einstein. So we click on that. So here the settings for the Einstein extension open, and I have that I can select the model that I trained and deployed. So this is my model deployed. I can have, of course, several models at a time, and I have to decide what to apply it to. So in this case, I have a sheet, and I want to be able to score this data. So I can use the worksheet and just select which worksheet I want to use. It's worksheet for ED, Einstein Discovery. Then I have to map the fields. So my data fields need to match the ones of the trained model. In this case, I have one that doesn't match. I have age that is called actually age full in my data set. So I can select manually, otherwise it is picked up automatically. Then I click next. I can use percentage as a unit of the probability, and then click on done. And voila, Einstein thinks a little bit about it, and the extension is set up, and you can score your data. Of course, if I select only one element, this can stay independent. For example, I do this. Yeah, and this person has 0% probability to go to premium. Really bad customer. Okay, of course, we can also use the predictions in graphs and scripts. So just to show you, in this case, I have a script, which is like this. So I have a script that takes the model definition with an ID, and then passes my fields to the script. And I also connected part of the fields to parameters. So in here I have parameters that allow me to simulate certain situations. So for example, here I have my users, and some pass to premium, but not many. And now I want to simulate what happens if I switch everybody to registered, just to simulate. I have much more probability for a bit older people to pass the premium, but not much yet for young people. So what happens if I wait for people to be a bit more experienced user? Now many more people, even in younger ages, they pass the premium. It might be that older people are a bit richer, so they tend to pass the premium even if it's not really necessary. It might be many things. In this case, I can simulate what happens in general. And if I switch to campaigns on December only, I have a really high probability for everybody to pass the premium. Okay, so thank you for your time. And if you need more information about Tableau and Einstein, or help with your data in general, you can contact us at where you can have a look at our website, first of all, www.argusa.ch, or contact us at info@argusa.ch. Thank you for your time, and see you in the next webinar.